which is equal to lambda times norm of x plus 1 minus lambda times norm of y. So norm is convex, right? So that is clear. What else? Can you give me a few other examples? Norm is convex, great. What else? That means, remember, sup norm is also convex. That means if you look at n-dimensional vector, look at the max of the absolute values, right? That is the sup norm. So even that is true because of, it follows from triangulus inequality again, right? So any other function, not so obvious, but okay. So I won't prove this. Geometric mean is convex. Okay, so I'll leave it as an exercise. You should see what is geometric mean. So can somebody tell me what is geometric mean? Arithmetic mean is the simple average, right? What is the geometric mean? I give n numbers x1 through xn. What is geometric mean? You take the product, right? And then nth root, right? That's what you have, right? So that is called the geometric mean. So you can think of geometric mean as taking a vector x1 through xn and giving me a number, right? It's a function. So I can so this function turns out to be convex. Okay, so now let's look at one more consequence of this convexity. So let's suppose you have a function f r into r is convex. Then what I'm going to do is I'm going to take 2 points in the domain of the function and pass a line through it, okay, and look at the value of the function along that line. So how do you write that? Then for xy belonging to Rn, let's assume that Rn is the domain, or I'll specifically write, so domain of f, you take 2 points. F of, what I'm going to do is I'm going to take x and ty, right? T is some scalar, x and y are vectors, x plus ty is another vector. Of course, I am assuming that this x plus ty belongs to the domain, so I'm not going to use some t that will take x plus ty out of the domain of the function. So this is, I will call this as g of t for a fixed xy. So you fix xy, and I will consider x plus ty. So t is a scalar, by the way, right? Is a convex function. Why is this useful? We will see right immediately after this. So let's see, what do you mean by this? So is a convex function for t belonging to R. Okay, so let's see. I need to prove that this is a convex function, right? So what do you mean by that? You look at lambda t1 plus 1 minus lambda t2. This is a convex combination of 2 points, right? T1, T2, right? Now I have to prove that this is less than or equal to lambda times g of t1 plus 1 minus lambda times g of t2. So let's see what does this mean. So this means f of x plus, so instead of t, I have to put lambda t1 plus 1 minus lambda t2. So what do we get? We get lambda t1 y plus 1 minus lambda t2 y. I'm just multiplying it, that's all. Now x, I can write it as lambda x plus 1 minus lambda x, right? Convex combination of x and x is x itself, right? So this will be f of lambda x plus 1 minus lambda x plus lambda t1y plus 1 minus lambda t2y. Simple algebra. Now what I'm going to do is collect all those with lambda. Lambda times x plus t1y plus 1 minus lambda times x, y plus, this will be x plus t2y, right? Well, the only, obviously x plus t1y belongs to the domain of the function. X plus t2y also belongs to the domain of the function. So it's a convex combination, so obviously it should belong to the domain, right? So now I'll use the convexity of f, right? F is convex. I'm taking 2 points